So we're working on solving logarithmic equations. So we're going to start this by doing our circle the wagon. So we take 2 to the 3x power should be equal to 32. So, 32 is the same thing as 2 to the 5th. So rewriting now with a common base, like we just did, now that we have the common base, we can set the exponents equal to each other. So that means x would be equal to 5 over 3. Same thing over here, circle the wagon. 3 to the negative 2 is equal to 2c. Well, 3 to the negative 2 power is the same thing as 1 over 9. So taking that, dividing by 2, c is 1 over 18. Circle the wagon. 2x to the negative 2 is equal to 16. So 2x to the negative 2 is the same thing as 1 over 2x squared. Well, that happens to be 4x squared. So if I want to solve here, I'm going to multiply both sides by 4 to get 1 over x squared is equal to 64. So then since my x squared is in the denominator, I'm going to take the reciprocal of both sides here and get that x squared is 1 over 64. So now I can take the square root of both sides. X should be equal to plus or minus 1 over 8. That's going to be our solution there. Circling the wagon here, 25 to the 1/2 power should be equal to x over 2. 25 to the 1/2, same thing as the square root of 25, which is 5. So 5 is x over 2, multiply both sides by 2. X is equal to 10. Circle the wagon, 8 to the 2/3 is equal to x minus 5. So 8 to the 2/3, you can take the cube root. The cube root of 8 is 2, and then 2 squared is 4. So 4 is equal to x minus 5. Add 4 to get that x is equal to 9. So here, we've got two logs that are equal to each other. The key thing here is that the bases are equal. If the bases are equal, we can take what's inside and set those pieces equal to each other. Since these are both log base 2, we can just say that x squared minus 6 is equal to 2x plus 2. Well, now we've got a quadratic. So I'm going to move everything to one side of the equation and then factor. So this factors to x minus 4, x plus 2. So we get the solutions, x is equal to negative 2 and positive 4. So one major thing to keep in mind at this point, we can have extraneous solutions. When we've dealt with logarithms, logarithms have the domain is x is greater than 0. Okay, so whatever is inside of our logarithm has to be greater than 0. So if you get, you have to check to see if your answers actually work. So usually we're looking out for the negative values because those cause problems. So if we plug in negative 2, negative 2 squared is 4, 4 minus 6 is negative 2. So that's a problem. Same thing if you plug it into the other side. 2 times negative 2 is negative 4 plus 2, which is negative 2. So we can't have that negative inside of our logarithm because our domain of the log has to be x is greater than 0. So we're going to have to toss out the solution of x is equal to negative 2 when we only have the one solution of x is equal to 4. So over here, we can circle the wagon. So we get x plus 4 cubed is equal to 27. So what we're looking for now is we want to see what number cubed is 27. Well, that's 3 cubed. So that means x plus 4 should be equal to 3. We can subtract the 4, x is equal to negative 1. Over here, circle the wagon. X cubed is 100, or 1,000. Take the cube root of 1,000 to get that x is equal to 10. Number 13 here, bases are the same. This one's nice and easy. The two pieces then would be the same, x is just equal to 12, and that's our solution. No extra problem there. And last one here, number 18. So same bases, So we can set the other pieces equal. X minus 3 is equal to 2x. So we subtract the x and get that x is equal to -3. But again, when we get a negative value for x, we want to pay attention, plug it back in, make sure what's inside your log there is positive. If we take -3 minus 3, we get -6. That doesn't work. We got to throw out the solution. This one's going to have no solution.